Okay, so in today's video, I want to show you how to solve a 3-variable system, but using a process called substitution. So the first thing we're going to do is pretty consistent from our past 2 lessons. We're going to label them A, B, and C. And then we're going to pick 2 equations. It doesn't matter which 2. You need to isolate just one letter from one equation. So if you want to do this the smart way, chances are, if you're doing substitution, there's already a letter who's isolated. So you notice how Z is all by himself? That means you want to use B in your pairs, for both of your pairs. So you can do either AB or BC, but you would want to do B. That would save you some work. All right, so I'm just copying down my A equation and my B equation. And you see how by doing this, I've already taken care of this step where it says isolate one letter from one equation. That's done right here. Z is isolated, and that's all I need to do. Then I'm going to take what Z is equal to, and I'm going to plug it in for Z in my A equation. So this is all part of step 3 right here. So we're substituting, and then we're going to go ahead and simplify a little bit. And then you want to combine your like terms, of course. You have no like terms with the y, and then any numbers I get, I'm just going to move to the other side. So I like that order to be x, y, and then my constant, just like that, and then you can draw your box around it. And that's step 3. All right, so step 4, you're going to do the same thing, but pick 2 different letters. And again, you just want to make sure that whatever you plugged in for, like I plugged in for Z in my first section, I want to make that the case again. So I want Z to be by himself, but if I use B and C, I'll be good because Z is already by himself. I don't have to do any work to make that happen. So I'm just going to jump right to the substitution. I'll plug that all in for Z next door. We're going to combine like terms. And this -1, I'm going to move over here. That way all my stuff is in order. And then put a box around that. And then step 5, we're going to finish this like we finish elimination. We're going to stack our boxes up, and we're going to pick a letter to get rid of. So I know for me, I would probably get rid of x's. And when I multiply by 4, my new bottom is such. And then I can add them together. And then divide, and I'll get -4 for my y value. So my suggestion is I would not even bother with substitution unless you can see right off the bat that you have an isolated variable. If you do, then just plug that in basically to each other equation, and you get a box every time you plug in, you get a box. So I would just do that, get your box, do it to the other equation, and get that box. Now that you got your y, you can put this back in either of your boxes. It doesn't matter which one. And then you get your x, which is -2. And then you can plug your y and your x in back to any of your originals. We're trying to get C, so I'm going to plug into this equation right here because that's hardly any work at all. And I know Z is 5 then. So I want to show you, sometimes kids are like, well, I don't like substitution, I'm not going to use that. And I agree, I'm not a big fan of substitution, but there are certain times where it really comes in handy. And I want to show you in this word problem how useful substitution can be. So sometimes it is the better route. All right, so we have a problem where these 3 boys, Jake, Natty, and Aaron, compiled all of their Algebra 2 homeworks for a total of 130 assignments. Now, I don't know how many each kid completed, I just know that when I add them together, it's 130. So we'll use a J for Jake's assignments, N for Natty's, and A for Aaron. Add them up, and it's going to equal 130. Then you notice you have one equation, and you need 3 of them. So my next sentence, it says Jake completed. So we're talking about Jake's assignments, which we're going to use the letter J for. Completed is the same thing as saying like he's done a total of. So when you are giving a total, that means equals. So completed is really the same thing as equals. It's your total. Then it says 10 more than natty. So obviously we're going to write 10. More or more than means plus. So we're going to do 10 plus whatever natty did. That's called translating. So we're turning just the words that are here into the correct mathematical symbols. And then we have one more. We have Aaron. So I would write an A. And then completed. Again, that yields a total. So we use an equal sign. And then it says 3 times whatever natty did. So to me in math, that means I gotta do 3 times n. And then if you notice, you have 2 variables that are already isolated, so you could just plug these in. I could take this stuff right here, 10 plus n, and plug that in for j. I could take this 3n, and plug that in for a, and I could just solve that whole equation then. Some kids feel a little shaky about doing it, but that's where substitution really would come in handy. I'll go ahead and do it using our traditional route just in case you're like, oh no, I don't think that's going to work. I'm worried that I'll mess that up. So then we label A, B, and C. We pick 2 letters. I'm going to pick A and B. And I'm just going to copy those equations side by side. Now I already have a letter who's all by himself, so that's a good thing. That means I can take all of this and I can put it in for J next door. And that's my new equation. And then I just clean it up a little bit and then box it when I'm done. Now I'm going to do the same thing. I'm going to pick 2 other letters. Let's say I pick B, C. I'm going to copy those equations down. Okay. And then now here's the rule. I took J out of the problem and replaced it. So I need to do the same thing. I need to take 10 plus n and put that in for J next door. But if you notice, there is no J next door. So technically, here's what's going on. Having 0 J's is the same thing as writing plus 0 J. It means I have no J's. But you could always add a 0 with the object to it. And if you plug all of this stuff in for J, the 0 is going to make it go away anyway. So you actually don't even need to do work. You can just write A equals 3n and box it up. That's what you would get from that. And then you can take your 2 boxes, and I probably wouldn't stack them up because they won't stack nice and neat. I would just take what A is equal to, and I would plug it in for A into the pink box. That's how I would do it. That's the easiest path for me. And then I would finish it from there. Get 24. Now the other 2 letters are going to be really easy to get. If if n is 24, all I need to do is add 10 to it, and now I got J. So J is going to be 34. And if I take my n and I times it by 3, I'll get my A term. So A is 72. But again, that's just an example where elimination probably would have been a harder route to take because none of the stuff stacks nice and neat. Substitution would have been a lot easier to do, just my opinion.